Hello and welcome to another session of mathematics lesson. In this lesson, we're going to look at variation, the second class in variation. But before that, let us go to the previous session of this subject. Welcome back. In this lesson today, we'll continue with the remaining two types of variation, which are joint variation and partial variation, and then we'll go over to application of variations. So let's quickly look at joint variation. Joint variation. The mass of a sheet of metal is proportional to both the area and the thickness of the metal. Therefore, M varies jointly as A and then T, where our M here is mass and then A here is the area, where T is the thickness of the metal. So we say that the mass of the metal is dependent on the area and then the thickness of that metal. Okay, and then another example is the football and air. Football and air. Without air, football is useless. When football is bought, the first thing that is done is to fill it with air. You pump your air in order for the football to be useful. Now, the air in the football determines the weight of the football and also the usefulness of the football. So invariably, it means that football and air are what? Joint variables. Okay, and then the relationship now that exists between football and the air is studied under joint variation. I hope that is clear now. Okay, so let us take an example. Okay, let's solve the question on the screen. It says y varies inversely, mark the word inversely, as x squared, and x varies directly as z squared. Then find the relationship that exists between y and z, given that c is a constant. C is a constant. Okay, let us start. We will solve this question part by part. Okay, the first sentence says that y varies inversely as what? X squared. Y varies inversely as what? X squared. You remember inverse variation, and therefore we have that y is equal to a over x squared, where a is a constant. A is a constant. Okay, in our previous classes we used k, but in this lesson I want us to use a as what? A constant. Okay, so y is equal to a over x squared. Similarly, we are told that x varies directly as z squared. So we have x varying directly as what? Z squared. And this is equal to, and this means that x is equal to kz squared, right? But in this example, I want us to use b in place of k. Okay, so therefore x is equal to bz squared. Okay, so we've gotten our y to be equal to, our y is equal to a over x squared, and our x is equal to bz squared. Okay, we just took them from here. Fine. So the first thing we need to do here is to substitute x equals bz squared in equation 1, and this is our equation 1. Okay, this is our equation 2. So in our equation 1, y is equal to a over what? X squared, and x is equal to bz squared. So because of the power here, we still add what? 2. Y will be equal to a all over, open this bracket, we have b squared z squared. Is that correct? But remember, in the question here we are told that C is given to be what? A constant. C is given to be what? A constant. So by that, A and B are also what? Constants, but can be replaced by what? C. So therefore we have Y to be equal to C all over Z raised to power 4. This is 4 because of Z raised to power 2 times 2 will give us what? Z raised to power 4. So it was a mistake. We have Y to be equal to C all over Z raised to power 4. Okay, then similarly, if we want to make C the subject of formula, C then will be equal to what? Y times what? Z raised to power 4. And that's just it. Okay, so let's quickly go to partial variation. Partial variation. In partial variation, we talk of two things that determine the output or the cost of a variable. Okay, let's take for instance a tailor trying to make a dress. Two variables are considered. And what are these two variables? We talk of the cost of material, and then we talk of the time that will be used to make the dress. Okay, now these two factors are the determinant of the cost of a dress. So if a dress cost $2,000 C, it depends on how long it took the tailor to prepare it, and then the cost of the material. So these two things determine the cost of a dress, and therefore we then say that C is equal to A plus KT, where this C here is the cost of making a dress, or the cost of purchasing a particular dress or clothes, where A and K are constants, and then T is what? Our time. Remember we said earlier that the time and the cost of material is a determinant of the cost of what? The dress. Therefore time is a constant, and then the cost of also is constant, because there must be time must be spent, and then the material must also be provided for your dress to be ready. So at that we have A and what? K as our constant. So let's quickly take the example on the screen. R is partly constant, partly, and partly varies with E. When R is equal to 350, E is equal to 1600, and when R is equal to 730, E is equal to 3600. And then the question is, find the formula which connects R and E. That's A. Then B, find R when E is equal to 1300. Okay, let us start. Solution. He said R is partly what? Constant. R is partly constant. So from the first sentence, if R is partly constant, therefore we have R to be equal to C plus K E. He said R is partly constant and then partly varies with E. That is the E here. Okay, where C and K are what? Are constants. Okay, now we now substitute the values of E and R. And here they told us that when R is equal to 350, when R is 350, E is what? 1600. Is that right? So we have R to be 350, and we have 350 to be equal to C plus K times 1600. So 350 will give us C plus 1600 K. Is that correct? So we call this our equation 1. Now remember too, when R is equal to 730, E is equal to 3600. So R has two values and E has two values. Now for the second value of R, which is 730, we have our C also plus E, which is 3600. So 3600 times K will give us 3600 K. We call this equation 2. Okay, now what do we need to do here? Looking at the two equations, we formed what we call what? Simultaneous equation. And all we need to do is to subtract equation 1 from equation 2. Okay, we subtract equation 1 from equation 2, and then we have 730 to be equal to C plus 3600K minus 350 to be equal to C plus 1600K. Then we subtract 3006 minus 1006 will give us 2000K, and C minus C will give us 0. Then 730 minus 350, what do we have? We have 380. Making K the subject of formula, we divide through by 2000, where this will cancel this. So K is equal to 380 all over 2000. 380 all over 2000. Okay, let's break it down. 380 divided by 10 will give us 38, and 2000 divided by 10 will give us 200. Then we have 38 over 200. 2 can go into this. 38 divided by 2 will give us 19, and 200 divided by 2 will give us 100. Okay, so our K is equal to 19 over 100. Okay, that's one. We've gotten the value of K. So we now substitute the value of K in the equation. Substitute the value of K in equation 1, which is 350 equals C plus 1600 K. 350 will be equal to C plus 160 into 19 over 100, which is the value of K. Then 350 will then be equal to C plus 19 times 1600 will give us 30,400 divided by 100. Okay, then we have 350 equals C plus 30,400 divided by 100 will give us 304. Okay, then we collect like terms. C then will be equal to 350 minus 304. Okay, and that will give us 46. So C is equal to what? 46. Okay, and then in the question A said we should find the formula which connects R and E. Now the formula that connects R and E is R equal to the value of C, which is 46, plus the value of K, which is 19 over 100. 19 over 100 E. So the value of E is unknown. And then the B part of it said we should find R when E is equal to 1000, 1300. So we substitute the value of E in that equation to be equal to what? 1300. Therefore we have R to be equal to 46 plus 19 over 100 times 1300. And then that will give us our R to be equal to 46 plus 19 times 1300 will give us 24,700 all over 100. Our R is equal to 46 plus 24,700 divided by 100 will give us 247. And then this added to 46 will give us our R to be equal to 293. Okay, having studied the remaining two laws of having studied the remaining two types of variation, which are joint variation and partial variation, please provide the answers to the following questions on the screen. Welcome back. Do well to use the lesson note on the platform for better information on the topic we've discussed. Feel free to drop your question or comment on the comment section. Until we meet in our next class, stay safe and bye.